Okay, last video for lesson 2, part 1. We're on page 4 of your notes, so this is not solving radicals, but it is just basic reminder of solving equations, because even though it's not an algebra class, you will still have to have these algebra skills. And you should have done statements and reasons last year. I'm pretty sure nobody liked doing those statements and reasons, but it's where we write down why we wrote our work down. So why did you write down 5x minus 3 equals 42? You didn't. So it was given to you. After today, I'm pretty sure at least in a week, you will never start with given. It will always be some other reason, but for now, I'm just handing you these equations. So let's remember how to solve this. If I see 5x minus 3, my goal is just to have the x. So I'm going to undo the process, kind of in reverse, whatchamacallit order? PEMDAS order, reverse, order of operations order. That's the word I wanted. So the opposite of subtracting 3 from something is to add 3 to something. So my second line is going to be the result of adding 3 to both sides. So I have a 5x here. 42 plus 3 is 45. Now before I finish solving this equation, I'm going to write down what I just did. If you add to both sides of an equal sign, you are using the addition property of equality. So that's what I'm going to put. So addition property, and I'm putting of equality because I added to both sides of my equal sign. So then, lastly, I try to get x by itself. This is a 5 times an x. I'm going to divide by dividing by the 5. So 45 divided by 5 is 9. That is my solution, and I got to that step by dividing on both sides of the equal sign. So if you remember, it's called the division property of equality. Most students don't like this process of writing out your steps just because they don't like writing this many words. But it really is just every time you do something, ask yourself, well, why did I do that? Or what did I do? I added first, then I divided. So I'm just writing the fancy pants name for add and divide. So on the next one, on number 14, I'm going to try to get x by itself again, but first, why did I write that first statement? Well, it was given to me. There's technically more than one thing you could do right now. You could take those x's and combine them, or technically you could move the 2 or move the 10. It's not wrong to do one first or the other. Usually people will combine those x's first, but it's as long as you put the reason for what you're doing, it's not wrong. So that's what I'm going to do. I'm going to take these terms, and they're on the same side of the equal sign, so I'm going to combine them. Well, x minus x is 0. So it's just not there. There's no reason to put plus 0 there. The thing that I just did is I combined like terms. This can also be called simplifying. Some teachers would have used that maybe with you last year. I'm not going to mark it wrong if you put that you simplified. It means the same thing. And I almost have x by itself, actually. Right here, x is almost on its own, except there's this plus 10 stuck to it. So I'm going to undo plus 10 by subtracting 10. Now notice, I'm not putting 10 minus 2. I'm writing 2 minus 10. So 2 minus 10 is a negative number, specifically negative 8. So I have my solution. I'm not going to write solution here. That's not what you put. You put how did you get that solution? And I got it from minusing 10. Fancy pants name for that is the subtraction property of equality. A good reason why you don't abbreviate here, because if you just put sub, we don't know if you mean subtraction or substitution. So I'm writing out to be very clear what I mean. So then this next one, we have an equation given to us again. Technically more than one way to solve. I can almost guarantee though, everybody is going to start by dealing with that 7 in front of the parentheses. So when it's in front of the parentheses, remember you multiply it to both terms inside that, to both the terms of that polynomial. 7 times x is 7x. 7 times 3 is 21. Then I have an equal sign, and I'm just going to rewrite what was on the other side of that equal sign. When you are multiplying it to all those items, I'm going to put the distributive. property. Now, this is not the distributive property of equality because you didn't do it to both sides of the equal sign. You only put the of equality if it's on both sides of equal. And now I'm going to keep trying to get x by itself. You could move any of these four terms. You could subtract 7x, you could subtract 21, you could subtract 23, you could subtract 6x. But you'll notice I said subtract lots of times, therefore we are about to use the subtraction property of equality. So it doesn't matter which one you subtract. I'm going to choose to subtract 6x. I was trained to always get the variable combined first, but it doesn't matter if you subtract something different. It does mean, though, that I don't have any x's on the right-hand side anymore. 7x minus 6x is 1x, so I'm just going to write x. You don't have to write the 1. But I do have to write the plus 21 equals 23. So then I'm almost done. To get x by itself, I'm going to move this plus 21. The opposite of adding 21 to something is to subtract 21. And you'll notice I just subtracted to both sides of my equal sign. And I'm going to be lazy, and I don't have to write mine twice. So subtraction property of equality, again, we get our final answer of 2. So just a bit of a reminder of solving equations, a bit of a reminder of justifying your work because, sorry, that does show up in geometry again. We do have one more on here, solve the equation below. Now, I will point out this is really similar to what we already were doing, except this squared. Ignore that for now. If you were simplifying an expression, the first thing you would do is dealing with the exponent here. But when you undo things to solve the equation, you work backwards. So I'm first going to deal with the minus 25. The opposite of subtracting 25 is to add 25. You'll notice it doesn't say to justify, so I don't need to put given. I don't need to put addition property of equality. I almost have x by itself, but I don't. I have x squared. So the opposite of squaring something, there's a function that's not add, subtract, multiply, divide. That is the opposite of squaring, and it's square rooting. It's a big part of the reason that we were just working on simplifying radicals. This cancels out the squared. And you could either work on breaking this apart, or you could realize, oh, hey, I know the square root of 25. It's the number 5. Quick side note, though. A lot of you probably were docked on this last year when you took algebra. When you solve by taking square roots, there are technically 2 answers. Now, I know 5 times 5 is in fact 25. But there's another number times itself that also gets me 25. Specifically, negative 5 times negative 5. So yes, the positive 5s make positive 25, but so do 2 negatives. So in algebra class, you have to write plus or minus 5. Now, luckily for you, this is geometry class, and most of the time we're just going to throw out the negative number because it won't make sense in the context of our problem. But if you're just solving a straight algebra problem, you should have that plus or minus with your answer. So, brief review on solving equations. Go practice on the assignment if your teachers ask you to start that, or maybe wait until class tomorrow if your teacher didn't mention anything about an assignment. But do make sure you have pages 3 and 4 in your workbook now mostly completed. And I say mostly because I did skip problems 11.